So just picking back up from where we left off, we see that there's a few interesting things with this mass spring system we had here, and also with this simple pendulum. Both do simple harmonic motion, as we were talking about, but there's a few interesting things. So first of all, I was just pointing out with this simple pendulum, it doesn't depend on the mass at all. If you did this with a kilogram versus something much, much lighter than that, then the mass has no impact on the time it takes to do the oscillations. Exactly the same motion will happen regardless of what the mass of on the end of the spring is. So that's really interesting. The other thing we see is that here, and also with the mass on the spring, we see that the initial amplitude, so where we started off, let's say we started it at this was some angle theta naught, we started it here and then we let it go. Wherever we start it off, as long as it's not outside of this range where simple harmonic motion isn't valid anymore, as long as we start it in this range, theta less than 14 degrees, it takes the same time to do a swing. There's the same period of oscillation regardless of where we start it off. And that's a really key fact. So same period of oscillation regardless of where you start. And that's odd, right? And why is that odd? Well, you might think, okay, well, I'll lift the thing higher up, and then it's got more ground to cover. So if I started it, up here somewhere, if I started it up here somewhere, and then let it go, it's got more distance to cover. This theta is bigger, so it's going to take longer. Just as you might think with this mass, well, instead of starting it, here with this A, what if I started it all the way over here? Well, clearly that's it's further away, so it's going to take longer. But that's not the case. In fact, regardless of where you start it, regardless of what this initial amplitude is, regardless of whether you pull it to here or to all the way over here, as long as you're not breaking the spring doing that, then the period of oscillations is the same. Why is that? Because you're giving the thing more energy. So although you're pulling it further out, so it's got more distance to travel, you're also going to make sure that it's moving faster while it does it. And so you give it a higher amplitude, you also give it more energy. I'm going to see that in our next slide in a moment. Just to run through some numbers quickly, so you have an example of how this would work. If you found that, for instance, you had a spring constant of, well, we'll just make things really, really simple. Let's say you had a spring constant of, your K was 1.
Hey guys, to continue watching this video and unlock hundreds of other super concise and exam board specific A-level physics videos, just click the Snap Revise smiley face. Join me today, and together let's make A-level physics a walk in the park.